Hi, I'm Zach from Pinecone, and in this video we are going to look at deploying a Jumphost into our freshly deployed AWS Reference Architecture with Pulumi. And as we mentioned before in the launching video, the purpose of the Jumphost is to allow you to interact with resources, including the RDS Postgres database, that are intentionally running in the private subnet of the custom VPC. So what we're going to do is provision a new EC2 instance that's running in the public subnet. We're going to SSH to that instance. We're going to grant that instance access to the Postgres database via security group rules. And then that will allow us to SSH into the Jumphost, and from the Jumphost to install Postgres as a client so that we can use the psql command line interface and then go directly to the Postgres database there. And so from our developer machine at home through the Jumphost and to Postgres, we'll be able to issue arbitrary SQL, check counts, talk about the database, modify the SQL as needed. And this is very useful for doing things such as either changing the database structure, investigating it, looking at it, or as I'll show in probably a separate video, loading it with additional test records in order to generate a ton of load on the system in general. So to begin, it's important to note that if you come into the repository for the AWS Reference Architecture with Pulumi, under the docs and linked from this table of contents here, there's a link for common tasks, and one of the first common tasks is talking about using a Jumphost. And so there are comprehensive instructions here. They include this flowchart to explain exactly what we're going to do. So this is what I just talked through. It's how we're going to go from the developer's machine at home that we're on through the Jumphost into the RDS Postgres private instance, and but still be able to issue arbitrary SQL. And so we're going to complete this process here on this video together, but just also be aware that at any time you can come here and follow the instructions in the common tasks guide. So to begin with, let us hop into our AWS account. We just deployed the reference architecture completely in a previous video. And so now the first thing that we want to do is go to EC2. In the EC2 dashboard, we are going to launch a new instance. So go to the instances interface here. So on the launch an instance interface, I like to name this either Jumphost or Bastion host so that I know which what job it has later on when I'm deleting it. You can stick with the default Amazon Linux AMI. It's also free tier eligible. T2 Micro, also free tier eligible. This is fine. The key pair login is essential. You must choose a key pair that you have or create a new key pair. This is will set up the SSH key pair both on your system by force downloading the private key through this browser interface to your machine, and then also setting up the authorized SSH keys on the instance itself so that you can authenticate to it using that private key. So if you don't already have a key pair that you've downloaded and set up correctly, then do create new key pair. This is one that I already have. If you don't select a key pair, you will not be able to SSH to the instance. And then the primary thing that we need to be concerned with from a settings perspective, there's a couple settings in here. One, auto assign public IP. So this is going to say whether or not when the instance comes up, it's going to have a public IPv4 address attached to it that will receive traffic. We do want that so that we can actually SSH to it ourselves. And so come in here, make sure that this is set to enable. The other most important consideration is that these are the various subnets that we have that the reference architecture deployed in the custom VPC. You'll note that there are both public and private subnets intentionally. So it doesn't matter which one, but it must be a public one that you launch the instance into. If you launch the instance into a private subnet, then your connection attempt with SSH will just hang silently forever. So the two changes here again, ensure that we do enable the auto assigning of a public IPv4 address, ensure that the instance is launching into a public subnet, one of the public subnets. The rest of this we can keep the same. Launch Wizard 2 is fine. We can create a new security group specifically for this instance. And as soon as we have provisioned it, we will then go and modify the RDS security group and tell the RDS security group that it can also accept traffic from this security group that the Jumphost is running in. The rest of this looks fine, with the exception that this SSH inbound security group rule that's going to be added for port 22, instead of allowing it from anywhere, that means, you know, the entire public internet of 0000, set it to my IP, and then this interface will detect your IP, use it, and that way only we can access this instance. It's not just hanging out on the public internet where it can be hammered. This is pretty snappy, provisioning a new instance, so shouldn't have to wait long. But we do need the instance to be fully available and running before we can attempt to connect to it. So there it is in a pending state. We can also note that its public IPv4 address is here, and we can actually copy this ourselves here. And then the other thing to note is that if you have just downloaded the private key, so I haven't moved mine into my .ssh folder, so it is actually here. You'll note that I have already chmodded it so that it's only readable by my user. You'll get an error if your key permissions are too open, and then you would do something like this, chmod, and then the path to your actual file. But because I've already done that, the actual SSH command is going to be ssh-i, saying the identity file, and then the path to that identity file. So the private key in this case, and then the user on that machine, due to the Amazon machine image that we chose, is ec2-user at, and then the IP address. So if we step back here, we can see, if we refresh, is this instance available yet? It is, it's running. And so now we can attempt to connect via SSH, accept the new fingerprint, and here we are. Now we're logged on to the Jumphost. The Jumphost is running in the public subnet, and the Jumphost does not yet have access to RDS because RDS is running in its own private security group. So to fix that, come in here, make note of or copy the specific security group name for this instance. And so let's just click into the instance itself. And if we go to security, get the security group is Launch Wizard 2, so just keep that in mind. If we go over here now to security groups, we can find the RDS security group that was provisioned by the reference architecture. Note that there are, by default and as codified in our Pulumi code, there are only 2 security groups that get access to RDS. The first is Pelican, because it needs to read directly from Postgres and listen for changed records. The second is the front end UI, because the UI issues SQL queries to the database and uses that for the table view. So we're going to come in here, edit inbound rules, add a rule. This will also be standard Postgres TCP rule, which means by default port 5432, which is what the reference architecture is also configured to use. And now we come in here and we say from which group, then it's the Launch Wizard 2 group that we just looked at, because that's where our Jumphost is running. Save these rules, and now our EC2 Jumphost does have network connectivity all the way to the RDS Postgres instance. But before we can actually connect to that RDS Postgres instance, there's one piece of housekeeping we need to do on this machine, which is first to search for the various packages. Depending on when you're watching this video, there may be updates and changes. In this case, I've been running with this, so Postgres 15, and the reason I'm doing this is so that I can get the psql client, and then from this Jumphost, now I have, right, so now I have this CLI installed, and now I can issue a psql command to connect directly to the RDS database itself. So for that, we come into RDS. We will find our instance that was provisioned via the reference architecture. We will grab the host name from the connectivity and security panel. So this endpoint right here that has the name of the database and then .rds.amazon aws.com, copy this. And the command is psql hostname is here. So paste the RDS hostname. The user we're going to connect as is Postgres. And this is coming back now from the RDS client, or from the RDS instance itself, asking us for a password. Okie doke. Here is the shared password. And if we pop that into the terminal, and so now that we are directly connected to the Postgres instance, we can issue arbitrary SQL. So count the number of records that are in the primary database, etc. And so now you have everything you need to modify Postgres or investigate it, change the schema, etc. Check out the triggers that we use in order to, if we do a describe table on products with increment, for example, then we can see here the triggers that are configured and the schema. So every time we delete or insert or update on products, we execute this function notify change that we've configured here. So that is how you connect via a Jumphost directly to the RDS Postgres database.